Chapter 3, Section 2.6, Part 2's video. On this problem, they're asking us to write an equation and basically look at it in terms of domain and range. So what we're going to do is we'll look at it. So the Clinton purchases $9,000 of photographic equipment to set up his studio. He estimates a salvage value of $200 for the equipment in 616 years. For tax purposes, he used a straight line depreciation. Well, seeing as this is a linear chapter, then we need to consider at time zero, he spent $9,000. And in 16 years, it was worth $200. So that's two ordered pairs. And we can do a linear regression if we want to. Or you can write the equation from this, looking at it. Here's your change in x. So it went up. Now here it went down 8,800. That's a negative 8,800. So slope would be change in y over change in x, which is negative 8,800 over 16. And let's see what that is. Negative 550. So the slope is negative 550. It went down $550 every year. Now, where did it start? The y-intercept is 9,000 because the x value is 0. So 9,000 minus 550 t. Put x there, put t. T years, right? So, but this is what I'm, you work it out by hand, that's fine. But I'm going to show you how to do it on your calculator and just do the linear regression. So doing linear regression, second plus 4 clears out all my lists, right? Go to stat, edit, make sure you're in L1, 0, enter, 16 years, enter. Now I've got 9,000. And then is it 250? No, it's 200. And then $200 in 16 years. Go stat, calc, number 4. We do want to store this because we're going to graph it. So I'll hit bars, arrow, enter, enter to put it in Y1, and then hit calculate. And it gave us exactly what we came up with by hand, right? Now we have that equation in Y1. We hit graph. Nothing's there, is it? Well, what I want to do is I want to move my x's out to x max out to 16. Make my x min meet -1. And we're just going to hit graph. It still doesn't show up. It's okay. I've set my x's. Now if I hit zoom 0, which is zoom fit, I can see it graphed. Okay. Now let's go back and look at this. We'll look at it as a table as well. Second window. We'll step that by 1. I want to start at 0. And as you see, it's going down. The highest point is 9,000. And in 16 years, it's 200. Okay, you can see how it decreases along the way. All right, so domain would be 0, 16. 0 to 16 years, right? And the range would be this, 200 to 9,000. The lowest Y value is 200 because that's at 16 years. That's what he's got left. The highest value is 9,000. That's what he paid for it. Okay, so just some things to think about and to use on the calculator. All right, now let's look at this equation. We're hitting a golf ball, and the inputs are time in seconds, and the outputs are height, right? So graph it, state the domain and range, explain why they tell us what they tell us about it. Okay, so let's look at the domain. We've got to graph this. So let's clear y equals negative 16x squared plus 4x, I think. No, 64, sorry. 64x. I'll put 2 million there. All right, so here's what we're going to do. We're going to hit graph. I just hit graph based off of my previous window limits. So I'm going to hit zoom 6. All right, so I see something going up, something going down as far as it's going like that. So let's hit zoom 0. There we go. So what we're going to do is we're going to concentrate just in this area up here. So we're going to manipulate our window just for a little bit. We're going to put 5, and we're going to put negative 5. Well, really, we could put negative 1 if we wanted to. I'll change that to 6. Now, Y max was 63, so let's put 80. And Y min, I don't need to see that. I can put negative 10, and we'll hit graph. Okay, now we want to know time is well, let's see. Let's go back and look. State the domain and range. Okay, so seconds, the inputs, how long is the ball in the air, right, after you hit it? So if we hit this, we know that it crosses at 0, 0, right? So what we're going to do is we can, I don't like it. I'm going to change that to 5. Matter of fact, I'll just change it to 10. Negative 20. There, it gave me just a little bit. It cleaned up all that crazy hash marks. So I want to find that point and then that point. So it appears to be 0, 0, 1, 2, 3, 4. Okay, so what I'm going to do is this. I can go to second graph. Now, if that's true, my output should be at zeros. And you can see it, 0, 0, or X is 0, output 0. That means it's on the ground, right? And at 4, the output's 0. So the domain on this is from 0 to 4, which would be, okay, the domain gives you the time the ball was in the air. Okay, so that's what the domain. Now we're going to look at what is the output doing. The output is how high it went. So when we're looking at this, the height at which it went up, let's hit graph, the height at which it went up is up here. how high. Well, how low was it? Well, it was on the ground, right? At 0, 0, we know it was the height at the ground. So my lowest point is 0. That's ground. Now, how high? So let's go figure this out. Second trace, I want to do a maximum because that's the top of it, right? How high? So what I want to do is I want to create a left bound. So I just want to come down off that hill just a certain point, hit enter. Now I want to go back over the hill to a certain point. Well, really, as long as it's not up at the very top, you're okay. You just want to come down that hill a little bit. Now I'm going to look in between those 2 points, those 2 left bound and right bounds, to find my max. When I hit enter, it'll find it for me. It'll say the max was at 2 seconds, which is great, but that's the next value, 64 feet. So when we look at this, the range went from 0 to 64. Okay, so that is 0, 64, and that is the height of the ball in the air. Okay, now we're going to look at these, and we're going to use these same type of things to get what we're looking for as far as the domain and range. We're going to graph it. So let's look at the first one. Let's go clear. Y equals, and let me go back. It's -7 t minus 8 squared. -7 plus squared. I think that's it. Yep. Okay, now I'm just going to hit graph. We can see that it gives me a portion of the graph. Let me hit zoom 6. All right, so it's a quadratic, okay, because it's to a power of 2. We need to open up our x's just a little bit. Let's go to 20. Hit graph again. There we go. Now we're seeing it. Now it's a quadratic. So quadratics, we know that the domain will always be, it's like a rubber stamp, -infinity to +infinity for quadratics. Okay. Now, so the first question was domain. -infinity to infinity, right? That's what it's got to be. And infinities always get parentheses. Okay, always get parentheses. Now, the hardest part now is just finding, okay, this quadratic is opening upward. So what is the lowest point? And that lowest point would be down here. So what we need to do is go hit second trace. We need to find a minimum. Okay, so we want to move it to about right there. Be on one side of that, and then I want to go to the other side. Okay, right there. And again, folks, that left and right boundaries encapsulating that. I hit enter again. It tells me that my minimum value is -7. So the lowest point, y value, is -7. The highest point is infinity. Okay. We can do it again where this one is -7 minus t minus 8. So let's change the equation to represent a minus that. So let's go over here. Let's go y equals. Let's go right here and hit a subtract. And now let's graph it again. Ooh, you can see it down there, right? Now, excuse me. It's quadratic, so we know, and we know it's quadratic because of this. So that's -inf to +inf. Now all we got to do is find, is it opening like this or opening like this? And if it's opening like this right here, then that would be a max. And if it's opening upward, this would be a min, right, for a quadratic. So this max would be the top point. Its lowest point would be negative infinity. This minimum over here would be lowest point, and the top point would be positive infinity, right? So let's go grab that point. I won't have to move my graph around any. I'll just keep it right there. Second trace, that's a maximum. So I want to look at my cursor. I'll make sure that it's going up so I can see. There we go. So hit enter. And I'm just going over to the other side. No particular place on the side. I just can't be on the top, right? It gives me a left bound, right bound. Now hit enter, and it tells me that my lowest point is -7. So that would be, well, let me go back. My highest point is -7. Okay. My lowest point would be that's a bracket. So what they've done essentially is this, folks, on this particular problem. They've just flipped it, and you note that it was going up with a point of -7, and then here on this bottom one it was going down at a point at -7. So it just reflected it about that point. It's what that did, opening up, opening down. Okay. All right. Okay. We'll pick this up in a second. Let's let this be chapter 3, section 2.6, part 2 video.